Hello everyone. In our previous session, we have already seen in what is the primal and dual, and what is the relation between primal and dual, difference between primal and dual. So this is one example: x1 plus 2x2 less than equal to 10, and x1 comma x2 less than equal to 5. x1 plus x2 less than equal to 5. So suppose x2, which is in our second variable, is unrestricted in sign. For example, we are given in the question, if x2 is unrestricted in sign, then we have to equal to sign in our second equation when we make the dual. Okay. In case in our dual equation, we are given in one variable unrestricted in sign. For example, x2 is unrestricted in sign. Then when we find the primal, our second constraint equation is must be equal to sign. Okay. And if the question is of maximization, then subject to constraint must be less than equal to sign. So this is our first example. See here, the maximized z is equal to x1 minus x2 plus 3x3. Convert from dual to primal. And the subject to constraint is, three equations are here: x1 plus x2 plus x3 less than equal to 10, 2x1 minus x2 minus x3 less than equal to 2, 2x1 minus 2x2 minus 3x3 less than equal to 6, and all three decision variables are greater than equal to 0. So the solution of this example is convert from dual to primal. So what is our first step? First step is what? If our dual is maximization form, then our primal is minimization form. So first we write the objective function minimize z. Got it? In our question, we use the decision variable x1, x2, x3. So in our primal, we use the decision variable in terms of y. Got it? The second step is what? Our objective function is to be subject to constraint, and our subject to constraint equation is to be objective function. So in our question, what is the subject to constraint? 10, 2 and 6. Then we write the objective function 10y1 plus 2y2 plus 6y3. This is our objective function. Got it? And the subject to constraint is what? The subject to constraint is, this is our objective function. So the coefficient of x1 is 1, coefficient of x2 is minus 1, and the coefficient of x3 is plus 3. So we write the subject to constraint in our primal. So first equation is what? This is our horizontal values. This is our vertical. So we write the vertical form and use the decision variable in terms of y. Got it? So our first equation is what? 1y1 plus 2y2 plus 2y3. And what is the sign? Sign is greater than equal to 0 because of our minimization is we write the always inequalities greater than equal to type. And what is the value? This values is our objective function coefficient, and the coefficient is x, coefficient of x1. Our second constraint equation is what? y1 minus y2 minus 2y3, and the inequality is what? Greater than equal to sign, and the coefficient of x2 is minus 1. So we write here minus 1. And our third subject to constraint equation is y1 minus y2 minus 3y3 greater than equal to what? Greater than equal to plus 3. So here all three decision variables are greater than equal to 0. Then we write y1, y2 and y3 are greater than equal to 0. Okay, got it? Our second example is, we are given in the minimized z is equal to 3x1 plus 2x2 plus 4x3. So our subject to constraint we are given in 3x1 plus 5x2 plus 4x3 greater than equal to 7. The second equation is 6x1 plus x2 plus 3x3 greater than equal to 4. The third equation is 7x1 minus 2x2 minus x3 less than equal to 10. The fourth equation is x1 minus 2x2 plus 5x3 greater than equal to 3. And the last equation is 4x1 plus 7x2 minus 2x3 greater than equal to 2. And we are given in the three decision variable x1, x2 and x3. First, we check if our question is minimization form, then all the inequality sign is greater than equal to type. Got it? But in case our question is maximization form, then all the inequality is less than equal to type. So, see here, our third equation is less than equal to type. But our question is minimized, then we convert less than equal to into the greater than equal to sign. So taking minus sign on both the sides. So this equation is convert into the minus 7x1 plus 2x2 plus x3 greater than equal to minus 10. Got it? So question is in maximization. So in subject to constraint where greater than equal to, question is given that we have to convert, this is your third equation, minus 7x1 plus 2x2 plus x3 greater than equal to minus 10. Okay, so our subject to constraint is, this is our objective function. Okay, and how many decision variable, kitne decision variable, 1, 2 and 3. So depends on our objective function. When we make the primal, we have three constraint equation. Got it? Because of all these coefficients writing our constraint equation. But in our dual, we have five constraint equation. See here carefully. We have five constraint equation. Then our objective function in the primal, we have five decision variables. Got it? That means what? Our objective function convert into the subject to constraint, and our subject to constraint convert into the objective function. So our solution is, first our question is minimization form, then our objective function is maximization form. Got it? So our objective function is what? We have the decision variable in terms of the y. So our objective function is maximize z is equal to 7y1 plus 4y2 minus 10y3 plus 3y4 plus 2y5. This is minus 10 because of we convert less than equal to into the greater than equal to sign. So this is our objective function. Got it? What is our subject to constraint equation? So our subject to constraint equation is what? 3y1 plus 6y2 plus 7y3 plus 1y4 plus 4y5. Our question is maximization form. Then we write the less than equal to sign. Got it? So greater than less than equal to 3. Our second equation is what? 5y1 plus y2 plus 2y3 minus 2y4 plus 7y5 less than equal to what? 2. And the last equation is 4y1 plus 3y2 plus y3 plus 5y4 minus 2y5, and the sign is less than equal to type because of our objective function is maximize z and less than equal to 4. Okay, so we write always y1 comma y2 comma y3 comma y4 comma y5 greater than equal to 0. So our next example is, this is very interesting example. see here, the maximized z is 3x1 plus x2 plus 2x3 minus x4. This is our objective function. And we convert dual into the primal. To subject to constraint, we are given in the two equation 2x1 minus x2 plus 3x3 plus x4 is equal to 1. And our second equation is x1 plus x2 minus x3 plus x4 is equal to 3. And we have four decision variables x1, x2, x3, x4. But in our condition, we are given in x1 comma x2 greater than equal to 0. But x3 and x4 are unrestricted in sign. Got it? We have already seen in our previous lecture what is the relation between primal and dual. So, what is the condition? Condition is that if we have unrestricted sign, so which variable is unrestricted? X3 and X4. So when we solve this problem, or subject to constraint, the third and fourth equation is must be equal to type. Okay, and in our dual, our first and second equation is equal to type. Then in our primal, our first and second decision variable is unrestricted in sign. Got it? See here. Here, third and fourth variables are unrestricted. That means x3 and x4 variable in the primal are unrestricted in sign. Therefore, the third and fourth constraint in the dual shall be equalities. Got it? The given primal problem is of maximization. The first two constraint equation in the dual we write greater than equal to type because of our objective function convert into the minimization form. Since both the constraint in the primal are equalities. See here, your question is subject to constraint, both the equation are equal to type. So, since both the constraint in the primal are equalities, the corresponding dual variable y1 and y2 will be unrestricted in sign. Got it? So, first our question is maximization z. So, we write the minimize z is equal to, we have 4 variable in our objective function. So, we have 4 constraint equation in our dual. Got it? We have 2 constraint equation. So, in our dual, we have 2 decision variable in our objective function. So, in our objective function, we have considered the variable y1 and y2. So, our minimized that is what? 1y1 plus 3y2. See here, 1y1 plus 3y2. And our subject to constraint equation. So, our subject to constraint equation is vertical type. See, 2y1 plus y2. Okay, 2y1 plus y2. Question is maximization form. We write a dual in minimization form. So, we use the greater than equal to type. So, 2x1 plus x y2y1 plus y2 greater than equal to 3. Why we write the value of 3? Because 3 is the coefficient of x1. Got it? Our second equation is minus y1 plus y2 greater than equal to what? Greater than equal to 1. So this is our first two constraint equation. But in our third and fourth equation, third equation is what? 3y1 minus y2. Okay, so our inequality is equal to type. Why? Because we are given in the two variable x3 and x4. x3 and x4 place value is third and fourth variable. So in our dual, we write third and fourth equation is equal to type. So the third constraint equation is py1 minus y2 is equal to 2, and the fourth equation is y1 plus y2 is equal to what? Is equal to minus 1. And last step is we write y1 comma y2 greater than equal to 0 or unrestricted in sign. So again we go to our question. Our first two equation are equal to type. Then in our non-negativity variable we write y1 and y2 unrestricted in sign. Okay, so this is our equal to type constraint equation. Then which is the number of equation 1 and 2. So in our dual we write y1 and y2 unrestricted in sign, and if our unrestricted in sign in our primal, then this number of equations we use equal to type. Okay, so this is very interesting question according to our dual and primal. Our next question is minimize z is equal to x1 minus 3x2 minus 2x3. Okay, subject to constraint we are given in these three equations where x1 comma x2 greater than equal to 0 and x3 is unrestricted in sign. So solve this example. We have x1 comma x2 greater than equal to 0 and x3 is unrestricted in sign. So firstly our objective function is minimization form. Then in our solution our objective function is to be maximization form. Got it? In this equation our question is minimization forms. So the inequality is always greater than equal to type. So if we solve any question, first you check all the inequality is according to our objective function. Okay, so I will continue this topic in our next session.